Okay, I see we have some people.
Yeah, let's just give everyone else maybe 2 minutes to connect.
Yeah, let's give it a bit of time. Okay, we're getting more people. Alex, by the way, are we using the Zoom from AA?
Yeah, we are.
So I should probably log in with the AA account, right?
I think it's fine either way.
It's a schedule one. Can you do it directly from the Zoom app, or do you have to go to the web version of it?
You can do it from the app as well. I usually just do it from my computer and I schedule it once because it's a recurring meeting. I don't need to do it again. It's
That's
just
cool.
the same link every time. Everyone can use it.
That's cool. So how many students do we have? 12?
I believe 12. I think we're still 2-3 short. Let me just check. Hmm.
If we're 12, we're all in now.
We are missing a few more. Just let me check. Mhm.
And for Zoom, when you record the meeting, does it save it locally or in the cloud?
You can choose. I usually save it locally just in case, but you can also choose for it to be a cloud link.
That's cool. Yeah, the Teams one gets saved in streams, which is quite nice because you don't have to worry about it.
Yeah, I save Zoom locally so then I can upload to Teams if I want to, but we also have a copy otherwise. Do you
Wow,
think it?
we have now 17 people, so 15.
Yeah. And there's still, I think, 2 missing.
Oh,
It's
really?
it's a big studio.
Okay.
Do you think it's? Would you prefer if we did it on Teams? Because I don't really have
No,
a
no, no.
preference.
I think if you guys use Zoom, let's continue with Zoom. Just
Okay.
so I see someone is recording already, so that's okay.
Yeah. I started up the recording before making you host.
Okay, cool.
But since you're host now, you can like pause it or.
No, no, keep recording. I think it's fine. As long as one of us records, it should be okay.
Yeah. Let's see. I think now we're good. Okay, I think we should start now because it's already
Okay.
7:34 anyway. So go ahead. Thank you so much.
Uh, okay, I guess I'm gonna start with a small video so you guys can see me. So welcome to Theo Studio. Um, it's gonna be a fun ride. I know you guys already, most of you have joined some of my classes, but I'm gonna assume you didn't, because I don't think everyone did. So we're gonna try to um, learn two computational frameworks this term. One is going to be a physics-based computational framework with something that is very similar to particles and springs. Maybe some of it you've already covered in Maya, I think, with Alex. And the other one, the other computation framework is going to be a growth-based um, framework, which I might assume maybe you've seen a bit of it when I was trying to show you Game of Life, which essentially was a bunch of cubes connected via some rules. So that's the goal for the term. Now, I'm gonna give you some code and I'm gonna try to enable you to write your own code. And I know how it works. So when we start, everyone gets on board, everyone will try to do it. The truth is, in each of your teams, and I hope at some point you decide what the teams are, or you have decided already.
Yeah, they're
Okay.
formed already.
So within the team, what happens is naturally someone is is stronger in this, right? And you have to remember that throughout the year, it's a team effort. It's never individual. And it would make sense that one or two person from each team really develops this skill and leads the computational development of the project, while other people develop other aspects. So in your projects, you're going to have a computational framework, also most times a geometry framework, also your project scenario, and throughout the year, other things. You might develop robotic prototypes. So you have to divide and conquer. The truth is, you can't do everything in the year. So while I do expect in the first term everyone to understand the computational framework, in the next term, most likely we will not have these big sessions with everyone. We're just going to have some sessions when we can discuss more specific things you're doing, right? And also um, what happens. And for example, when I was a DRO student, uh, for my term, Mustafa and Manu at the time were showing us some computational frameworks that at the end for my project, we didn't use at all, right? We ended up making our own framework, which is what I'm hoping most of you will end up doing. So I don't want you to feel like these frameworks that I'm showing you, you have to use them in your projects and they have to dictate the way you do your project. But I do hope that having this in your bag as ways of doing things, you'll be able to make your own version, right? And again, this requires a certain level of dedication from whoever picks up the coding. Um, it's not enough to just take what we give you. It has to be also a lot of self-thought. You have to go a bit mad about it for a while. And usually, what happens in the summer break, most people get a bit of time, and when autumn comes, you get people who really spend the summer like 2 3 months developing this, and that's when things get really interesting for us or for you as well. Okay, so I guess let's get going, and I'm gonna keep my camera on because honestly, I think it's nice to see the faces. And you always get these funny moments where someone has the camera like this or like this. Or yeah. Um, so let's see. So, all right. So I'm gonna share the screen. I guess my desktop one. Uh-huh. So I have to grant Zoom system preferences access. 1 second. Okay, I guess. Now can I? Yeah, now I can. Let me know if you see the screen.
Perfect.
Okay, cool. Sorry, I'm a noob to Zoom. I don't really use it that much. All right, so, oh wow. So when you have, I guess I can minimize it. And this thing still goes here. Can you like that? Oh, there we go. All right, so let me quit this thing that I was actually doing. Okay, so when you start Unity, you usually will have this Unity hub, right? And I expect everyone has installed Unity and you have the hub. Now, what we're gonna do, I'm gonna also upload my code to GitHub. So I haven't yet set it up, but I'm gonna set up a GitHub for us. Now, I don't know if you use GitHub or not, but maybe in the next session, I'll also show you how to set up GitHub as well. So then we can share the code a bit more easy. But for this session, what I'm doing, I don't need to share the code. So when you start Unity, you have this hub, right? And you can add a local project that might have been downloaded from GitHub, say, or you can make a new one. So we're gonna make a new one, and you see when you do new, you have also a drop-down option here. And if you have multiple versions of the Unity engine, you can choose which version. And if you go to installs, you can see I'm using 2020.2.1F, and you can add multiple versions. So for example, there are pre-releases. So for example, the latest one is 2021.1, which has a lot of great features, but it's still quite buggy. And let's say the ones we're using so far are the official releases. So you can see there's already a version that is better than what I'm using, 0.2.3.f1, I guess, which I'm assuming you guys have, because most likely this was no longer there. So I might update mine at some point. But you can have multiple versions of the engine. Now, I would argue anything that's in official releases is okay to use. I wouldn't recommend to go to pre-releases because they have a lot of bugs, and I don't think you have yet the skill level to understand the bugs to use them. Later on, definitely, because pre-releases generally come packed with new features that are super exciting. All right, so I'm gonna make a new one, and I'm gonna name it somehow that I can upload it to GitHub. Um, and I'm actually gonna save it directly to my GitHub folder. Okay, and I guess let's name this. I guess you're 2020, no? And should we call this TO Studio?
Yeah, you can like just say TS or something.
Yeah. Okay, so that's gonna be where I'm gonna add most of the hub. Now, I don't generally recommend to have everything in one project because it tends to get convoluted, but we're gonna do it in one. Now, on the left-hand side, you also have to choose a few frameworks. So you can choose a 2D framework, a 3D framework. Then there are some rendering pipelines, like a high definition. There's a universal render pipeline, mobile, and mobile 3D. Well, we're not gonna get concerned into these ones because these are optimized rendering pipelines. So one is for like very powerful desktops. These are for mobile phones. And there's a universal one that allows you to totally customize scripting your own rendering pipeline, which again, I don't think you guys will do in the beginning. So we're just gonna go with the 3D framework, which is pretty much the empty 3D project. And it's using the built-in render. Okay, now let's go with this. So I think I did that already. Yeah, I did it already. Okay, now quite important. Every time you make a new project, essentially what happens, and you can actually see here, you copy the local version of Unity to another folder. And this is quite important. Unity is not like the other softwares we use, not like Maya, not like Rhino. So for example, when I make a new Rhino file, I don't copy the whole Rhino, right, from my system. Well, Unity works like that. Whenever you make a new project, you copy the entire Unity engine. Well, in reality, you don't copy the entire engine, but you copy the way it's assembled and the way it builds. But you can think of it as copying the entire thing for now. And this is quite important because I guess let's use default. Oh, come on. Oh, come on. I know what I did. I'm sorry about that. I'm using some custom. I'm using some custom layouts that you guys probably don't have in default. Okay, so I'm gonna have to, it is already, okay, so it reset it to the default layout, which I guess maybe it's good to go over it quickly to just get ourselves familiarized uh, with the layout itself. So when you start Unity, you have the big window, that's your scene. Next to it, you have the game window, and they're pretty similar. So the scene is where you build everything. The game is a view inside the scene, right? Which is given by your main camera, right? So every scene you start will always have at least a camera and a directional light. And the camera points somewhere into the scene. You can kind of see it if you zoom out, right? Okay, so that's the scene view. If I look inside my scene, I have a few options to how to display it. I can go into wireframe mode, shaded wireframe, and I'm gonna stick to shaded, and then a bunch of other things that are for debugging, which we're not gonna cover for now. You can also switch between a 2D view of the scene or a 3D view. There's also a perspective and an isometric view, so you can switch between viewing the scene in a few ways. You have your gizmo, which again, I'm assuming most of you would be familiar with from other softwares. And if you click on the gizmo, it gives you some projections that you can use. And then a bunch of other buttons that turn on the lighting, turn off the sound, and so on. Also, you have some grid settings, and you can set up also snapping. And I'm going to talk about snapping a bit later. And then you have your gizmos. So gizmos are these helpful things that identify objects. So for example, my main camera, if I zoom into it, you're gonna see has its own gizmo, a little icon that makes it look like an icon. And the light has a little icon that looks like a sun, okay? Then we have in our next window, we have the hierarchy. And here you have listed all the objects that you have in your scene. And this is very similar to the Maya hierarchy. So you can make an object to be a child of another object by dragging onto that object. And now whenever you move that uh, parent object, the child follows along. You can unparent by dragging it out. Um, so that works very, very similar to how Maya works. Okay. Then to the right, we have the inspector. So whenever you select something, it gives you information about the object. So for example, this is my main camera. I can change the clipping plane. I can change the field of view, right? So if I go to something more human eye, like 35, that's usually human eye 35 or 32, depends on if you're wearing glasses or not, yes. Okay, so that's the inspector. Then you have your main project, and this is nothing more than a way to see your explorer, right? So if I go and say, hey, show this in Finder or Windows if you're Explorer, it just shows you on your hard drive where these things live. So for example, if I make a new folder here, it should have been called tests, but it ended up called tests, I guess. You see it's also here, and you can delete it. And if I delete it from there, in my Finder, Siri, I don't want to talk to you. You see it disappears. So it's nothing more than a way to explore what exists on your hard drive. Okay. Now, Let's explore the top bar because we do have one. So we have here a bunch of tools. You have your select tool, your pan tool, which allows you to pan, which honestly, I never do it with a tool. I just use middle mouse. Then you have your move tool. If you select an object, you get the move gizmo. You have the rotate tool, which allows you to rotate something. And you can rotate on constraint on axis, or you can rotate well, on constraint. There's a cool trick that a lot of people miss initially. You can reset some transformations if you mocked around with some things. Now, the other two we have is the scale tool. Then we have, well, let's make an object. So I'm going to go to game objects, 3D objects, and I'm going to make a cube so you can see this guy. And I'm going to reset roof. I'm going to reset its information. And if you press F, you frame the object. So very Maya-like. Now, in the scale tool, I can scale on all the axes, or I can scale on one axis at a time. I have also the rectangle tool, and this is a very useful tool because it allows you to sort of distort in a few axes at a time. And then you have the combine tool. So this sort of is all in one. It's moving, scaling, rotating, all in one. Now, quite important for your transformation tools, you have pivots. So you can have a pivot that is either centered or set up in your software. So for example, in Maya, you can set the pivot in another position. And you can set to use the global axis, or you can use local axis, right? So for example, if I rotate this guy, now my local axis is this. And if I switch to global, you can see it's aligned to the world system, right? So again, I am assuming most of you will feel comfortable with this. Then grid snapping, you can use it if you want. There's something I wanted to install. So if you go here, there's something called quick search, and by default is not installed. And yes, go ahead and install it. So this is a very useful tool within Unity that allows us to search for stuff, okay? And for example, I want to change my grid snapping. Okay, I'm gonna make it that it snaps every unit of space instead of, now I think it's a quarter of a unit. Compile. This. Okay, so when you start quick search, it asks you for some settings. We're gonna leave it to default. Medium and default. All right. And now if I go to my Unity, where the hell did it go? There we go. And if I go in here, quick search, I get this pop-up menu where I can search for things, and I'm gonna search for snaps. And you see it gives you everything within your project that has snap inside of it. So I have an interface and a snap engine. Well, I want this grid and snap settings. Double click on it, it gives you the snapping, and now it's actually set to 1. Okay, no, the increment is 0.25. Okay, let's increment to 1. So every time I snap to the grid is 1 unit of space. Okay, so let's close that. I'm gonna delete my cube. And I'm gonna make a new one, a 3D cube. Okay, and let's reset this guy. Now, how snap works, if you're on a Mac, you hold command, and if you're on a computer, you hold control, and now you can snap in one increment, right? So for example, if I duplicate, which is command D or control D, and I hold command or control, I can go and snap up, right? And this allows me to work in units of space. All right. Now let's talk about the bread and butter of all Unity. So whenever you make something, and I'm gonna delete these guys, everything in Unity is called a game object, regardless of what it is. So if I look at my main camera and my directional light, They're both game objects, okay? So in Unity, whatever you make, it's a game object. And there you go, we have here something called game object. And I can make an empty game object. So this is pretty much the basic game object, okay? And any game object that you make, and let's reset this guy. Come on. Any game object you're going to make is going to have a transform component. So regardless of what it is, it's always going to have the transform component because you need any game object in the world to be locatable. You need to know where its position is, and you also need to know its rotation. So I can see I can move this empty game object and I can rotate it, and you can see the values change indeed. And I can even scale it, even though it's an abstract game object, right? So I don't really have anything. Now, how game objects become specific is by adding components to them. And think of the components as pieces of code or behaviors that you're going to add to the object. So let's say I want my object to be some shape. And for the sake of actually having a shape, let's model something quickly, I guess, in Maya. You guys are used to Maya, right?
Yeah.
Okay, so we're gonna model something quickly in Maya just to have some geometry that we can bring inside of our game. And also quite important, whenever we're gonna model something, especially in Maya, what we want to do, so I forgot my password. How did I forget my password? Okay, so until I can reset that, let's just go with the cube. All right, so if I want to get the cube inside my world, I will need a few components, okay? So if I go into the next menu item, I see here I have components. And I know that in any game engine, geometry is represented through meshes. So if I go to meshes, the first one I have is something called a mesh filter. Instead of a filter, think of it as mesh shape. I think that makes a lot more sense. So you add a mesh shape, and to this, now I have nothing plugged in, and the mesh filter or mesh shape expects you to give a mesh object or a mesh shape. I can click on this circle, and you see there's some built-in Unity shapes. I can select my cube. Okay, now interestingly, I've added the mesh cube, but I still don't have anything. And that's because rendering is separate from actual geometry. So I have to go to game object, sorry, to component, to mesh, and to add a mesh renderer, okay? And if I do that, now my actual geometry is now shown. Now, if you remember when we were doing the class, I was telling you that Unity has a really interesting way of communicating to us. So whenever you see pink in Unity, it means there is some problem. And I guess they made it pink instead of red to be cute. So it tells us there's some problem with this object. And if you look at it, what seems to be the problem? What is it missing? We have a light, right? So it shouldn't be equally lit, right? This object. So if you think about it, this object has no materiality, right? Well, that's because we haven't actually assigned a material to this object. And if I go to mesh renderer under material, you see here it's expecting you to give a material and now has nothing. And again, we can use one of the default shaders. And when I do that, now it starts to behave like I would expect. So the face that is facing directly the sun is more bright, the indirect face is more dark, and the back face, well, obviously very dark. Okay? Right, so that's very cool. So that those are components. Now, what happens if I want to make something that no one has made before. So obviously I have a bunch of components. I have mesh components, I have all sorts of effects, even physics. And physics are really fun to work with. And just so we see a bit how physics work, I'm gonna move my cube a bit higher up, and I'm gonna make, let's call this, and I'm gonna make another 3D object, and I'm gonna call it floor. And let's scale this guy to be maybe 100, well, let's keep to 1 and 100. Okay. Now what I want to do, if I want to use physics, if I get my object and move it higher up, I need to first define this object shape in terms of its physical appearance. And how do I do that? I go to component, physics, and I need to give this guy something called a collider, and I'm going to use the box collider. Now, this seems like nothing happened, but in reality, if I look closer, there's like a green line all over it. And this represents the actual collider, which I can actually edit. So if I want, I can make my collider a bit bigger than my shape, which I can actually make it a bit bigger so you guys see what happens. Okay, now I have a collider, but in reality, if I go into play mode, which should jump me to my camera instead of the actual scene view, and I can see the cube is actually static, it doesn't actually drop. Let's do something. Let's go and set up our camera so it actually looks at the cube. And I think it's now here. Yeah, it's underneath. Move it slightly back. Whoop. Okay, so I would expect this guy to fall. Well, it doesn't fall initially, and it needs something called a rigid body. And again, maybe you've seen some of this in your Maya tutorials. So for this object to actually use gravity, I need to go to components, physics, and add something called a rigid body. So when you add a rigid body, you get a few properties, one of them being the mass. And you can tell it to use gravity. And what's the gravity? Well, again, I could use the quick search. Oh, it didn't find it. Ooh. Well, I know where it is. So it is in Edit, Project Settings, and I have somewhere in here Physics. And you see the default gravity is set at minus 9.81, which I'm not sure if you remember from school or high school, is the amount of force Earth pulls any object towards its center. Yeah, so that's our gravity for now. And interestingly, if I go and play, what's happening? Can you hide? That's funny. Can this go away from the view, or I'm stuck with it forever? Okay, so if I go into play mode, it sort of went, and I can see that the cube fell to the ground. Okay, now that's all great when I have objects that I can use, components that the people from Unity developed, but most of the time you'll end up making your own components. Okay, so let's do something. I'm gonna make a 3D object, sphere, and let's reset this guy. Oops. All right, so let's also place this guy a bit above the ground, and I'm gonna also add to this guy. And by the way, you can add components also in this manner. Let me select the sphere. Let me move this out of the way. So you can also add components directly here, and you see it's the same menu, and you can search for stuff. So I want a rigid body because I want my sphere to fall to the ground. But I want to control this sphere with my keyboard, okay? So what I'm gonna do I need to make myself some script that controls it, okay? And let's go into my assets. I'm just gonna make a new folder. I'm gonna call this scripts. And inside of here, let's make a C# script. Let's call this movable. Okay. And if we double click on it, we should get into our default script editor. I'm using Visual Studio. You can use anything you like, but I would prefer if you switch to Visual Studio. Otherwise, things might look a bit different for you. And let's see what I have in here. So whenever we make a new script, we are welcomed by the script editor with a bunch of mumbo jumbo. At the top of the script, we have something called libraries. So these are collection of scripts that are available to us. And by default, we're using a few very useful ones. So we're using for our operating system collections. This allows us to store data and, well, manipulate data. And we're using Unity Engine, which is pretty much the main engine, the functionality of Unity. Also, we get then what's called a class. And this class will always have the name of the script, which in my case is called movable. And we see something that is 2 dots mono behavior. Well, this tells this class to inherit all the properties that mono behavior has. And I can see that mono behavior is part of Unity Engine. So the class, the library Unity Engine, comes with something called mono behavior. Okay, and mono behavior is pretty much the stuff that acts inside of Unity. Okay, whenever you're gonna see this, it's something related to Unity. And what's the advantage of that is that our newly made piece of code will inherit all the functionality that Unity has. Now, within the mono behaviors, you have 2 functions that are set by default. One is a start function and another is an update function. Okay, so it's self-explanatory. So start is called first time you run the game, and update is run as fast as your computer can run things. Now, besides functions, you have something called variables. And let's do this so we see them a bit easier. Okay, and these guys are. So you can use variables, and variables are data points or data information that you can store in your computer memory. So I know I want to use to move my sphere. So maybe the first variable I need, and again, if you were in my class, you might remember this, there is a scope to the variables. And generally they are defined something like this: scope, type, name, and value. So you have to define what is the scope. A variable can be either used only within the class itself or structure or whatever you use, or it can be accessed from outside. And that's defined by either being a public, which means it's accessible. It can be accessed from outside the script, or it can be private. Okay, which means it's only to be accessed and modified within the script. Now, I kind of want to be able to change this outside of my script. So I'm going to use a float, which is a type of variable that allows you to store decimal values. And this is going to be a speed value. So I guess the speed at which this sphere will move. And then we're gonna need, and let's make it also public. Maybe initially we can set it up ourselves. We're gonna use a vector. with 3 inputs, vector 3, and we're going to call this direction. All right, so what happens? Well, in my update, I want to calculate the new position of my sphere. So if I look into my sphere object, where is position? Well, position is under transform, right? And I'm gonna set this to 2. And I need to change my floor to be at 1.5. Actually at 1, I guess. Yeah. Okay. Also, please be mindful that in the Unity world, the axis system is flipped. So Y is actually up. Oops. Right? So whenever you change Y, it's up. X is left and right, and Z is away from the computer monitor and close to the computer monitor. Okay, so I want to set the position of this. So in order to do that, we need in our script to go and say, hey, from this particular object, get the game object, and from the game object, get the transform, right? And from the transform, I want the position, and the position will be, I guess, should we do plus equal? Yeah. So maybe this is a bit confusing. So we're going to use a shortcut. So to the value of the current position, I'm going to add my speed multiplied by direction. Okay. I could have written this without the shortcut, without plus equal. So it would have been something like this, but it would have been very long. Right. So this would have been also, these 2 lines are exactly the same. This is just a shortcut to say, hey, to the position, add the value of that. But it's exactly the same. These 2 lines. It's just one is a lot shorter, as you can see. I'm gonna take out the long one because it's annoyingly long. All right, so I've now made this nice little component. So how do I use it in my game object? Well, I need to go inside of Unity. I need to select my sphere, and I can select this new script that I made after it compiles, and I can, well, I can drag it until I see this blue line. And now I have set up this script. The other way to do it, which is my favorite way because it's a lot faster, add components, type in here, movable. All right, so let's set up the value of 1. So I want this guy to move every frame 1, unit up. So if I go into my game, let's pull the camera a lot further away. Okay, so if I go inside of my game, now I should see that sphere. What? Why is it not moving? Ah, idiot. I need to set that speed to some value because now it's multiplied by 0. So if I set to 1, there you go. Okay, I think maybe 1 was very big. So let's set to 0.01, the speed. I think now I set it too small. So let's set it to 0.1. And it's interesting what is happening. You see, it's fighting the gravity. So the gravity is pulling the sphere to the ground, and my speed is multiplying, well, 0.1. And I guess if I set it to 1, it just goes up. Okay, I might take out the rigid body for now, or maybe let's leave it. So the rigid body is going to push my sphere down, but I kind of want to move it with the mouse. Okay, so what I want to do in order to actually move it with the mouse, I want to use the input system that we have in Unity. And if I go in here and I go to project settings, I see I have something called input, if I can find it, input. And in here, I have a few axes set up. I have a horizontal axis. And it sort of says, well, the name is horizontal, negative button is the left from keyboard, positive is right, or alternative, it can be A or D. Okay. And then I have also something called vertical, which is pretty much similar, which has the button set as down and up, or S and W. And gravity is overriding with 3, the value. Okay, so what I want to do, I want to go into my little script. And for here, I'm gonna use another type of very useful variable. And this is a generic variable, which is usually set, whoa, not shader. So I want the variable x for the x-axis. And I want another variable y for the y-axis. So what I'm going to do, okay, so let's set them as private. And he's not happy. Let's use it within our update. Let's just do something like this. Variable x, and this is going to be input because we want to use from the input system. And we want to say, hey, get axis. And what axis? Well, let's say this one gets the horizontal axis, right? And then I'm going to use another variable y, and this one is going to be from input. We're going to get an axis, and this one is going to be the vertical. Perfect. Now what I want to do, let's put some notes in here. So we want to calculate the axis based on input from the keyboard. Okay, so what we do, the first step, get the keys and axis. And then next step is to make or update the direction vector. Okay, so how do we do that? Well, quite straightforward. Direction. We're just going to, I guess, let's just make it from scratch. So we're gonna make a new vector 3. And in here, we're gonna say, hey, x, then 0, because we know y is actually up, and then z. And sorry, y. And maybe just to be consistent with Unity, we're gonna call this z and call this one z as well. Okay? So this way, whenever we input something from the keyboard, it's going to be updating the direction of the vector. Okay? Perfect. Let's save this. And let's go to Unity. I am now gonna make my speed value. Let's set it to 0.5 maybe. And I'm gonna reset this because I'm gonna just change the value of my direction with the script itself. Now, if I go into play mode, There you go. I am now controlling this sphere with my mouse, with my keyboard, right? And I can collide it with stuff. Okay, very dodgy collision. Okay, so let's make it a bit more interesting. So I now have I can call this maybe the player, I guess. And let's make a obstacle course for our player. Or actually, let's make it something more interesting. Let's generate some type of dynamic grid through which I can go and push them around. So I want to get this cube, and let's just reset it. Let's frame on it. And let's maybe place it at, I think, 1 or at 2, sorry. Okay, so what I want to do essentially, I want to create some type of a grid that will look something like this. And I want my sphere to be able to go through them, but I'm not going to do it manually because this will take me forever. I'm going to use a bit of scripting to generate a grid. Okay, so in order to do that, I'm going to go and reuse this cube that I can see has already a rigid body attached to it. And I'm going to make a new folder. And let's call this prefabs. So whenever you want to reuse something from Unity, you can go from your hierarchy, get the cube, drag it inside your assets, and you get something called a prefab. Now, you can see that my cube from the scene has become blue, and I get an arrow. Well, when I click inside the arrow, I get into what essentially is called the prefab editor. So whenever I modify something to the cube itself, I guess maybe I want to scale it slightly that is a bit bigger in this axis for some reason. And I get out, I can see that that has updated. Let's do a copy and let's move it. And let's go now into the prefab. Let's change the scale back to 1. And whenever I go back, there you go. All the other cubes that are instances of the prefab get updated as well. Okay, so I'm also going to change my sphere to be called my player. And for now, we're going to control the player, but at a later stage, it can have its own decision-making system. So what I want to do, I want to create some type of a grid. So I'm going to create an empty object. I'm going to call this a grid. And let's reset this to be at 2 in space. And what I want in this grid, I want to instantiate, make a bunch of copies of these cubes whenever I start the game. So I'm going to make a new C# script. Let's call this grid manager, I guess. And I'm going to select my grid. Oh, what's happening here? Okay. I'm going to go into my grid and add the grid manager to this guy. And let's modify a bit this script. Now, the first thing I want to do, I want to make a reference to my cube. So what is the cube? Do you guys remember from Unity? What are all the objects called? Anyone? Let's make this interactive. I'm gonna select some people from here. So I don't see the names.
Just open participants. It should open on the side.
Okay. Yes. Zoom, 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 zoom. Oops, not this. Ah, cancel. Until Okay, you're speaking. So what are in Unity all objects? What are they called?
Game objects, I guess, but I don't know.
Yes. So I'm expecting you to know this from the classes we already have, but as I'm saying, no one actually attended them, or maybe they did. Okay, so we need a reference to our little cube. So this is a game object, right?
Can I ask a small question?
Absolutely.
What might I have some compile errors that have to be fixed, like, and I can add the grid manager to the grid. What that could be?
Okay, that can be a lot of things. You're gonna have to develop the skills to figure out what doesn't work. So if, for example, you have compile errors, it could be that you missed to put a semicolon. It could be that you missed to have one of the curly brackets. It can be quite a few things. What I didn't say, and I was sort of hoping you already know this, you have the console, and whenever you get an error, it will tell you in there somewhere more or less what the error is. And it's pretty accurate, like 99% of the time it tells you what the error is.
Yeah,
And
I
again,
remember that part, but the thing is that we've done nothing at the grid manager script, right? It's an empty script. So
it
what?
is, but the way Unity works, so for example, I'm gonna make an error myself as well, just so you see it. So I don't know, let's put cube in here, and I will on purpose forget the semicolon. I'm gonna forget about it, right? Save it, and now I should get an error if it compiles. Come on, compile. Okay, let me close my other Visual Studio. Okay, now it compiled. So you see, it gives me an error, okay? And you can't go into play mode until you fix all your errors. And the console will tell you more or less what the error is. So it's telling me, hey, have a look at assets, scripts, grid manager C#. In line 7, you have an error, which is CS1002, C# error 1002, which is already telling you I'm expecting a semicolon, right? And usually if you double click on the error, you will sort of get you exactly where the error is. Or depending on the error, some errors are a bit more tricky, but most times you'll work like this, especially when we have something really simple. Come on, Visual Studio, load. Okay, so you see it brought me to line 7, and it's saying, hey, I'm expecting a semicolon. No, I don't want to update. Now, if I save this and go back to Unity, hopefully it will compile. Come on, compile.
Okay, I just saw that I have a problem with my library, in my library. With package gas.
All right, then you've installed wrongly Unity, and you might need to install again. I think your link to Visual Studio is not set up as well. Let's see how that works. So by default, it should be set up, but sometimes if you don't install correctly, it doesn't. So if I go into, where the hell is it? Nothing build settings. It should be, I don't know how it works in Windows, but you should have something called preferences. And in here, there is something called external tools. And you need to select from the list Visual Studio, and sometimes it's not set up like this. And yeah, if you don't have it, you might need to manually set it yourself. Or if you haven't installed correctly Visual Studio, you might need to reinstall it. When you install Visual Studio, you need something. Oh boy, you will need something in. Where the hell is it? Extensions, game development. You should have something called Visual Studio for, and I guess if you're on Windows, it's for Windows. But usually when you install Unity, you have by default set this to be installed for you. So make sure you've installed it correctly. Otherwise, it won't pick up all these parts with the libraries and so on. Okay, so let's go back to what we have here.
Thank you.
So now in our grid, I see now that I have a reference for my cube, and I'm gonna go to my prefabs, and I'm gonna drag the cube prefab into my grid. Now I've made the reference to the cube. I'm gonna delete this one, and I'm gonna delete this guy as well. And I'm gonna actually move my sphere a bit back. All right, so what I want to do in my grid, I want to make a bunch of these cubes set out in an array with a bit of spacing. So I'm gonna have a variable, maybe called spacing, and let's set it to be equal to 1.0. And if you guys remember, whenever you're using a float and you set the value, you have to put an F at the end. So this is quite important, don't forget it. All right, and then I want to use internally a game object array. And remember, arrays allow you to store multiple objects inside. Let's call these cubes. And actually, let's call this grid because it is a grid. Yeah. All right, so what I want to do at the start of the game, I want to actually create my grid. So I want to create it by initializing or instantiating so I want to copy or instantiate multiple cubes. And I also want to have an integer. Let's call this size in X. And I want another integer, size in Z. Okay. Cool. Let's jump to Unity. Compile. Come on. I have an error with my Visual Studio, which I hope you guys don't have. But for me, sometimes it's, yes, override. Takes a while for that thing to compile. Come on. Update. Oh. This sucks. Okay, now it compiled. Okay, so now if I go into my grid, I now have the size in X, and let's say I want 10, and size in Z, I don't know, 5. And spacing, I want them to be spaced 2 units apart. Okay, that's good. Now let's go and actually build our logic for instantiating all these objects. So whenever you instantiate an object, you need to tell where that object lives in the world, and also you need to specify its rotation. Okay? All right, so what we need to do, yeah, I think the best way to do it, we're going to go and we're going to use 2 for loops. And again, I expect you remember a bit of this. So we have for loops that allow us to do something multiple times. So we're going to start our first for loop, which is going to count using an integer called I. And the I will start at 0. I will be stopping to count whenever it gets to size x. And it will increment with the value of 1. All right. Then I'm going to have another for loop. And this time I'm going to use another counter called j, which is going to start at 0. It will stop counting when it gets to size x. And it will increment with 1 as well. All right. Oops, in here it has to have a semicolon. And now I want to create a bunch of cubes based on the values of I and j. So what will we need? So remember, we need a position. So what is position? Well, it's a vector. And I'm going to use here a vector 3. And again, maybe to get you used to this idea of variables, actually, let's use vector 3. So let's call this position x. Actually, vector 3, let's call this position because it is position. It's going to be a new vector 3. And this guy expects you, and actually get used to using Visual Studio because look, if I go and type in vector 3 and I put in brackets, you see here it gives you the options. I have 3 options. One is just an empty vector. Then another vector that you give 2 variables, x and y. Then there's another one that takes in 3 variables, an x, y, and z. Okay, so what do we want here? Well, we want our I. Then we know we're not going up in the world, so we're going to use 0. And then we want a z value, which we know is going to be j. Okay, so that gives me the position of the new cube to be placed. Okay, now what I want to also do at this point, I also want to specify how it's rotated. And I know that initially all my cubes shouldn't be rotated. And in Unity world, rotations are handled by something called quaternions. Just don't get scared about them. They have a very funny name. They're really complicated to understand, but really easy to use. And I'm going to call this one rotation. And for this one, what I'm going to do, I'm going to use a built-in quaternion, which is called identity. And identity is essentially a non-rotation. So it's a 0, 0, 0 rotation. Right, so now I have my position and rotation, and I now can make my new cube. And I'm going to use a variable, new cube, and this guy is going to be instantiate. And now when I put instantiate, it gives you a few options. So the first option is to just give an object that you want to instantiate. Then you have one that you can give an object and who is the parent. And then you have another one, which is object parent. And if it should be instantiated in wall space rotation, well, I'm going to jump through them. The one that we actually want to use is this. What is the object? What is its current position? What is its current rotation? And who is the parent? So I want to use this one. So what is the object? Well, the cube is the object. Then you have to give it, and you see how it highlights the position. Well, we want the pose. Then it goes rotation. Okay, I want rotation. And then who is the parent? And the parent, well, it's this script game object. And from the game object, you need a transform actually. Okay, so what I actually made in this script is I'm instantiating a new cube at the position which is being incremented by I and j with no rotation. And this is going to be a child of the grid. Okay, now I don't really need the update function. Or maybe we'll do something later. So let's keep it in there for now. So let's save this. Come on, compile. It's really annoying. I really need to fix this. And didn't compile. You shouldn't have this problem, but I am gonna fix it soon. Oh, come on. It's really refusing to compile. This is so annoying. Okay, if you ever get this error, let me do something. I have a scene here. Let's save as. I'm gonna go into scenes and call this session1. And I actually need to restart Unity. It's quite annoying. I hope you don't have this problem. If you get it, usually it's a problem between Visual Studio linking to Unity. And tends to happen when you have multiple instances of Unity open, which I actually had. So let's see. Yes, it has compiled. That's fine. Now let's see this working. So if I go into play mode, I do have my cubes made, but I have a feeling I've created them. Yeah, I have. You see, I've created them somewhere into Ether. So let's do something. Let's move our, yeah, because y should be 2. Yes. Otherwise, it will just fall to the floor. So let's put here 2 instead of 0. Let's save this guy. Now it's compiling perfectly.
Octavian, if you could show us again just the script, just to have a check on.
Yeah, sure.
Yeah, thanks.
Okay, now if I go into play mode, boom. I have my cubes that I can run through. Whee! They're not exactly spaced the way I want them. And anyone knows why? And how to fix it? Whee! Let's go in here. So what do I need to space my things? I do have spacing set out. So what do I need to do to make them more spaced apart? Big hint is position. Well, I have to multiply the value of I and j by spacing. Okay. So now they will be further apart, which is exactly what I actually want. Okay, let's go into play mode. There we go. Now I have my grid into this checker pattern. Somehow I managed to somehow get the ball through them without hitting many of them. It's quite amazing. All right. I think we're almost at the 1 hour and a half mark, so maybe let's stop there. But let's set out a small homework for you. So let's do this. What's gonna be your homework? Well, let's also do something in here. So in the grid, we're going to add, actually, yeah, let's add. And what do we want to add? New cube. Ah, yes. Oh, really? Ah, come on. Yeah, it's not initialized. God damn it. Okay, so we're not gonna use an array. We're gonna use a list. And inside the list, we're gonna use as type game object grid. And we actually need to initialize it. So it's gonna be a new list of game objects. Because we don't actually know how many we want. But actually we do know. Yes, let's do it with an array. I want to use an array because it's much more easy to use. So let's just do game object array, and we know this is gonna have two variables, grid, and this is going to be a new game object array size. It does exist. Okay, I know why. Boom. Oh, come on. Okay. So I made my grid. I have now initialized it, and then I am going to do something quite clever. Okay. All right, so I'm saving this cube that I'm making in a data structure. And I want your homework. So this is gonna be your homework. Let's do something with this grid. Yes, let's update the rotation. So your homework in the cubes in the grid. So that's your homework, to spin the cubes in the grid. So how we might go about it? I'm gonna give you the pseudocode for this. Loop. Well, actually, you need two loops. to the grid array and get each get form rotation and then update. So this is sort of pseudocode of what you need to do, okay? And I would like you to search into Unity how you do rotations and how you change the values, okay? For this, probably the best way to do it will be Unity docs. You have in here the manual, and you have here also the scripting API, plugin rotation. Will give you a bunch of things in here. One of them is transform rotation, which you can read how stuff works. But again, I'm gonna leave it to you. You can also just Google Unity rotate, and usually will get you to the right place. And there you go. There's even an example, which is using time delta time, a perfect way to rotate something based on how much time it has passed since the last frame. So that's your homework, okay? Save this. So next time we start the class, I'm also gonna do the homework. So we should have in our grid a bunch of spinning cubes. So when we go into our play mode, so come on. We'll have a bunch of spinning cubes. Now they're sort of static. I can collide with them, but they're sort of static. Cool. Well, have fun with this, okay? Any questions? No questions? Amazing.
If you guys have no questions, I think we can wrap up the class. I will be sending the recording through. I'll probably make a Teams channel like we did for the workshops as well. So there we can also exchange recordings, and also if you have any other questions during the week, you can post there and we can try to catch up with you even before the next class. Thanks for joining. The next session will be on Friday.
Cool. You have a bunch of time to do this homework. If you're gonna be ambitious, make a 3D grid and make that sphere that I control now only on 2 axes. Maybe you can pick it with the mouse and move it to the space. So that would be a fun challenge if you really want to challenge. The rotation challenge is really easy. Like honestly, it will take you maybe 1 hour. Do it even less. Okay, cool. Also, as we go, we're gonna pick up speeds. And again, I am saying that I expect you not to know much, but in reality, I do expect you to have some knowledge because last time we spent quite a bit of time in Unity doing tutorials. Now, if you feel you don't remember much of that, there are a lot of courses online that cover Unity scripting. And I would say maybe at least cover the basics of it. So you should feel fairly comfortable about the way I'm writing functions, the way I'm writing data structures, the way I'm writing, well, we'll get to a point where we're going to use classes. So I really want it to be comfortable to write code. I don't expect it to know the game logic and how we make these things. So we're gonna do all of that together. But at least the basic skills of being able to read and write code, I do want you to have it at this point. So I'm gonna try to go very slow, but something that I am going to sort of assume you're comfortable with. So whenever I'm doing this sort of making a variable, making a function, you should be, I know how that works. Let's see. Okay. Cool. Well, have a good week ahead. And I'll see you, and we'll see you all on Friday, okay?
All right. Thank you, guys. See you on Friday.
Ciao.
See you. Thank you.
Thank you.
See you.